Hello everyone. In this video I'm going to explain about the motion of electron beam in the electrical field. So as you clearly seen here, there are basically the two plates. There are two horizontal plates. One is above plate, and that above plate is connected to the positive potential of the battery, and the negative plate and the another plate is connected to the negative potential of the battery. So it means that inside these, inside these two plates there is electric field. As soon as electron enters, if there is no any kind of the field, external field, the electron has to go in the straight line path. But what happens, here the electron enters with the some velocity v. So it will, its path will not be straight line because of the electrical field, and it will deflects in this way. So here I have written the same thing. Let us move ahead. So the potential difference between the two plates may be, then we know that electrical field intensity will be the Pd divided by the distance between the plates. As the distance between the plates over here, the distance between these two plates is small d. Then actually E will be equal to V divided by B over D. And then now, as we know that the force on an electron, the force acting on the electron will be given by F is equal to E times E, and this, in place of this capital E, we can actually write V over D. So this force is actually directed toward the positive plate, because the electrons are carry the negative charge, and they are attracted towards the positive plate. The positive plate is in the upper, in the upper side. So the force is so this is, and the electric field is in vertical direction. No horizontal force is acting on this. Yeah, because the electrical field is in the vertical direction, but there is no any force in the horizontal direction. So that's why there is no any kind of the the deflection in the horizontal motion. So actually we can find the acceleration, but this acceleration should be in the vertical direction. Acceleration is equal to F by m. So F is equal to E times E, and over mass of the electrons. So now actually what we actually get is, x is equal to v times x equal to ut, as we know the formula. So that's why x is equal to v times t, and y is equal to ut plus 1 by 2 at square. So as the initial velocity is 0 along the y-axis, because if you look carefully, like in this first figure, the whole velocity, this initial velocity is acting in the x-axis only. There is no any velocity in the vertical direction. So that's why I just replace that by this particular, y is equal to 1 divided by 8 square. So y is equal to a. In place of a, we have already calculated the value of a as e divided by me, and in place of t, actually we can write x over v, because x is the, the distance traveled from here to here, and the velocity, the velocity along the x-axis is v, because this velocity is not affected. Okay, this velocity is not affected. That's why in place of t I have actually written x over v. So that's why if I again put the value of capital E as v by d, we will get the relation like y is equal to ev divided by 2m dv square times x square. So this equation is in the form of like y is equal to k times x square, so which is the equation of the parabola. So we can say that the path of the electron in the electrical field is the parabolic. Okay, so this one is like that. And then when the electron just passes the plate, when the electron just completely passes the plate, then the horizontal displacement will be equal to the length of the plate, and the length of the plate is capital D. That's why we can do like this also. Again, if we want to find the velocity, So no problem, v is equal to u plus at, we know that formula, and then vx is equal to v and vy is equal to u. Uy means velocity along y axis is 0 initially, so that's why a times t. We have the value of a, we have already calculated, and this is the value of the time d over v. So in this way we can actually find vy and vx. The angle at which it emerges out, or we can say the direction, will be tan theta is equal to y by vy by vx. So okay, now I'm going to the next part, and that is the motion of the electron beam in the magnetic field. So when the, let us consider the electron beam moving with the speed v, horizontally enters the uniform magnetic field of the magnitude b, acting perpendicular to the direction of the motion. So as soon as the electron enters into the magnetic field, the force acting on it will be given by F is equal to BeV, because this is the force due to the magnetic field. So this force actually provides the necessary centripetal force to the electron. The direction of this force is perpendicular to both B and B. The speed of the electron is unaltered, but the path is deflected from original path. So the force BeV provides the necessary centripetal force. So just we can actually write BV is equal to mv square by r, and then we can find the value of radius as mv divided by be. So this radius is also called the Larmor radius, and from this relation we can actually find the time period as well. By actually we can convert this v to the omega v, because v is equal to omega r, and again in this way we can actually find the time period as well. So thank you very much. I have, in this video I have just explains what actually the the motion of the electron in the electrical and the magnetic field. So thank you.